Often in human-agent interactions, smiles are perceived as positive social signals. However, smiles represent a spectrum of emotions, including embarrassment, discomfort, and nervousness. The differences between these smiles can go unnoticed, which may result in them being classified as the same. Detecting these nuances between positive and negative smiles would enable researchers to build more receptive virtual agents capable of connecting with humans at an emotional level. While datasets containing Duchenne and posed smiles exist, there are currently no video datasets for in-the-wild negative affect smiles. Thus, we developed a dataset specifically for this. Here are some examples. We analyzed the composition of negative affect smiles to determine what action units differed between smile types. We discovered a statistically significant difference between AU12 and AU26, as well as noticeable differences between AUs 6, 7, and 17. Here is an example of a nervous smile depicting lip corner puller, jaw drop, and lid tightener. This example shows lip corner puller and cheek raiser. To detect negative affect smiles, we built a CNN and Bi-LSTM classifier that attains an F1 score of 58% for negative smile classification. We utilized a VGG-based CNN that is pre-trained on 2.6 million images with 2,622 classifications. This was passed into a 32-unit bidirectional layer and then a 64-unit dense layer. From there, the output enters a dropout layer to reduce overfitting, and then another dense layer, followed by a 50% dropout. Finally, we have our binary classification layer via softmax. To compare the performance of our Bi-LSTM model, we trained an SVM with dynamic time warping distance. This model utilizes OpenFace feature generation. OpenFace detects AU intensity from the training examples. The SVM uses this to make its predictions. This model attains an F1 score of 67%, a baseline for our dataset. Here are some correct predictions. Now, some incorrect predictions. The need for more data is clear. However, collecting videos of negative affect smiles is quite laborious. Other areas for future work include utilizing facial alignment, scene context, as well as gaze and head orientation. When we analyzed the incorrect predictions, it was apparent that a lack of contextual data in the model could be a factor impacting our classification accuracy. We as humans gain significant contextual information that the model does not have access to. That is all for our presentation. Thank you for your time.